Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 15th, 2025, about 2 days ago. The big idea is a simple but powerful combo. This paper stitches a latent text-to-video generator to a feed-forward 3D reconstruction decoder, then aligns them with direct reward fine-tuning to produce high-fidelity, 3D consistent scenes that beat prior Gaussian splat methods. The paper is titled VIST3A, Text-to-3D by stitching a multi-view reconstruction network to a video generator. And as we'll see later, the results are really impressive. In short, model stitching uses a tiny unlabeled dataset to match internal layers, the reward encourages multi-view quality and 3D consistency, and the framework works across several video generators and 3D backbones, even enabling high-quality text-to-point map generation. Also, the authors shared the GitHub repo. You'll find the official VIST3A code scaffold, a demo video and assets, and a README outlining the pipeline and released VIST3A 1.3b and 14b models. Setup and quick start are still TODO, with placeholders for training, model stitching, and reward alignment, so expect an early stage release. That setup set the stage. Figure 1 illustrates what the stitched pipeline delivers from text prompts. The left panel, labeled Panel A, presents text-to-3D Gaussian splats with small colored insets that indicate predicted depth or geometry cues. The right panel, labeled Panel B, demonstrates text-to-point map outputs that retain coherent scene structure. Together, these examples show consistent multi-view geometry and high visual quality, because the generator and decoder operate end-to-end. So, while Figure 1 showed what the pipeline produces, Figure 2 contrasts how to get there. The top panel depicts prior practice that trains a fresh 3D decoder from multi-view latents, which is data-hungry and often misaligned. The bottom panel presents the proposed route that stitches into a pre-trained feed-forward 3D model, then aligns the video generator, so latents decode reliably into consistent 3D scenes. Model stitching means connecting networks at compatible internal layers. Alright, Figure 3 details the method in 2 stages that make text-to-3D scenes reliable. The top panel presents model stitching, which means inserting a small linear adapter between a video encoder and a pre-trained feed-forward 3D model so their internal features align. The bottom panel shows direct reward fine-tuning, which nudges the video generator during its denoising steps, using rewards for multi-view quality and 3D consistency. Together, these steps yield decodable latents that form coherent geometry. With the method in place, Table 1 shows that VIST3A clearly leads the benchmarks. The stitched models score the highest imaging and aesthetic quality, and they top the coherence metric that reflects multi-view consistency. Unified reward means a single composite score that blends quality and alignment signals, so higher values imply better overall scenes. WAN plus AnySplat and WAN plus MVD UST3R both outperform prior Gaussian splat systems across T3 bench and scene bench. Wrapping up, 2 takeaways stand out. Stitching a latent video generator to a pre-trained feed-forward 3D reconstructor, then aligning it with direct reward fine-tuning, unlocks high-quality, 3D consistent scenes with minimal data. The broader implication is modular 3D creation that is faster, scalable, and flexible across backbones. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.